Right, in this video, we're going to take a look at the arrangement of electrons in atoms, more specifically ions. So a couple videos back, I took a look at atoms and ions. So atoms become ions when they have more electrons or fewer electrons. So they either have more electrons than the number of protons or fewer electrons than the number of protons. That's how they become ions. So electrons are negatively charged, right? Negative electrons. And protons are positively charged, positive protons. So when you have more negative electrons than positive protons, you're going to have an overall net negative charge, right? Because there's more of these negative stuff. When you have more protons than negative electrons, you're going to have an overall net positive charge because there's more positive protons than negative electrons. And in the previous video, we covered how the number of protons never changes because the number of protons determines the type of element it is. So if you have 7 protons, it's going to be nitrogen. 2 protons, it's going to be helium. So the number of protons never changes, but the number of electrons can change. And that's what causes ions to be formed when there's a different number of different number of electrons than the number of protons. And so in this video, we're going to look at the arrangement of electrons in atoms, more specifically how the number of electrons can change to have more electrons or fewer electrons than protons, causing ions to be formed. So ions having a net positive or a net negative charge. So if you look at the periodic table, it's made up of these squares, right? My next video is going to be on the periodic table, so just wait for that if you haven't seen it, if you don't know. But it's essentially the periodic table is made up of these tiny squares. And here we can see helium, and 4 and 2, nitrogen, and 14 and 7. We don't really care about the top number. The top number for now is just the mass number, which tells us the number of protons and neutrons added together. But the bottom number is what we're concerned about right now. The bottom number tells us the atomic number. And the atomic number tells us the number of protons. Number of protons. Now, why is this important? Well, the number of protons, as I said, is equal to the number of electrons. That is in its default state when it's not an ion. Once it becomes an ion, the number of protons and electrons differ, right? But for now, at least when you look at the periodic table, the atomic number is the number of protons as well as the number of electrons. So it's not only the number of protons, but it's also the number of electrons. So if we draw a dot and cross diagram, so that's how we draw diagrams of atoms. We have helium in the center, right? This is going to be the nucleus. So it's going to have 2 protons in the center. And we also have 2 electrons. Because number of protons and electrons are the same, right? So what atoms want to have is they want to have in order to be stable, they need to have a full outer shell of electrons. So what atoms want to do is atoms want to have a full outer shell. I'll go into depth of what this outer shell means in a minute's time, but just look. Atoms want to have a full outer shell of electrons. Why? To be stable. Once they're stable, they are unreactive. So this helium here currently has a full outer shell of electrons. It has 2 electrons in its outer shell. We're gonna look at nitrogen. Nitrogen, we put an N here. 2, and we have 5 more to do. So 1, 2. Now we fill in the electrons in a clockwise direction, one at a time. So 1, 2, 3, 4, 5, 6. One more. So they're all put in positions like this, clockwise with 2 in either side. So this nitrogen currently has 1, 2, 3, 4, 5, 7 electrons and 7 protons. So it's not an ion. This helium currently has 2 electrons and 2 protons. So it's not an ion. Now, this helium has everything it wants in its life. It's living in the Maldives. It's rich. It has a luxury villa. It has everything it wants because it has a full outer shell of electrons. Now, you might be wondering, how is that possible when this has more than 2 in its outer shell? Well, this is why. The first shell, the shell is what the electrons circle the nucleus in. So the nucleus has protons, right? So the protons kind of pull the electrons together. And these electrons circle or orbit the nucleus in what are called shells, these circles. Now these are called dot and cross diagrams. So we represent the electrons with these crosses. The first shell, this, can hold a maximum of 2 electrons. So this helium currently has a full outer shell of electrons because it has 2 out of the 2 possible spaces in its outer shell. However, everything after the first shell, so this is the first shell, we count the shells from the inside. So this is going to be the second shell, right? The second shell can accommodate a maximum of 8 shells. Third shell can accommodate a max of 8 shells too. Fourth one too. So everything but this first shell can hold a maximum of 8 shells. And until it has a maximum of 8 shells, it is not fully stable, because it still wants to have a full outer shell. So it needs 8 out of 8 electrons in its outermost shell. So this currently has 1, 2, 3, 4, 5 out of its 8 possible shells, right? Because it can have, not 8 possible shells, 8 possible electrons, right? Because the second shell onwards can have a maximum of 8 electrons. Currently only has 5. So it has 5 out of the 8 possible electrons. So what does it want to do? It wants to get a maximum of 8 electrons. So that's why this is very reactive and it's unstable. This helium, since it has a full outer shell of electrons, is very stable and it's unreactive because it has everything it wants in its life. It doesn't want any more money. It doesn't work. It just stays there. This nitrogen, it sees these Lamborghinis driving by, these luxury villas, and it wants that. So it strives. It tries to get it. So it's very reactive and it's unstable because it wants to have more electrons. Now what this does is it tries to receive electrons from other atoms. And when it does, we'll look at how it does this in coming videos. But so when it does, this nitrogen currently has 7 electrons, right? So 2 in the first shell and 5 in the second shell. 1, 2, remember we fold them out in a clockwise direction. 1, 2, 3, 4, 5, 6, 7, right? It needs to have 3 more to become stable. Or it can actually lose all these electrons. But think about it, atoms are just as lazy as us humans. It wants to take the shortest path possible. It currently has 5 out of 8. It doesn't have 3 out of 8 or something like that. When it has 3 out of 8, it's easier to just get rid of your 3 electrons than receive 5 new electrons, right? But this already has 5 electrons. So is it easier for it to receive 3 new electrons or to get rid of all these 5 electrons? It's much easier. It's less energy intensive to just receive 3 new electrons, right? So in coming videos, we'll look at how it does this, but somehow it will receive these electrons from different atoms. And now it has a full outer shell of electrons. Now with our dot and cross diagrams, we represent that with these circles. These are new electrons that it has received. And now it has become an ion. So it's become charged. To represent ions, we draw these brackets like so. And it currently has 3 new electrons, right? So before becoming an ion, it had 7 electrons and 7 protons. So it was a neutrally charged non-ion atom. But now it received 3 new electrons. So now it has 10 electrons, because 8 in the outer shell and 2 in the inner shell, right? So 10 electrons compared to the number of 7 protons, because remember, the number of protons never changes. So it currently has 3 more negative electrons than positive electrons. So now this is going to have a net overall charge of 3 minus. Why? Because it received 3 new electrons, right? So once it receives new electrons, it's going to become negatively charged, because it has 3 more negative electrons than positive protons. These 7 electrons are cancelled out by the 7 protons, but these 3 aren't cancelled out because there's no more protons to cancel these out. So it has a net 3 minus charge. And by the way, then the minus comes after the number. It's just how it works. So there's a net 3 minus charge because there's 3 more electrons than the protons. Let's take a look at helium then. Helium has 2 out of 2. So it has everything it wants in its life. It doesn't need any more. So it just stays like that. This nitrogen atom, 3 minus charge. 3 more electrons than the protons. And atoms want to have a full outer shell of electrons because they want to become stable. Otherwise, they will be unstable. So, let's take a look at one more example. We can have sodium. By the way, the atomic name for sodium is Na. If you look at the periodic table, you'll see this. Remember, this is the atomic number, and it tells us the number of protons. Now, in its current state, the number of protons is equal to the number of electrons. Every element in the periodic table has an equal number of electrons and protons. It's only when it becomes an ion that it differs. So we're safe to assume that this is not an ion, and the number of protons and electrons are the same. So if we draw this, we're going to draw sodium like so. 11 protons in the nucleus and 11 electrons. So 1, 2. Second shell. Remember, the first shell can only hold 2. 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we drew 8, 9, 10, and we need 1 more. Oops, I'm running out of space. I should have accounted for this. I regret this. Anyways, there's going to be another electron here. And notice how I filled it out. It's 1 on each side, 2 on each side maximum. And we fill them out in a clockwise direction. So 1, 2, 3, 4, and then we go back and fill it one more time. And then when we have a new one, we put them at the top here. So it currently has 11 electrons and 11 protons. But notice how in the outer shell, now it only has 1 electron. So what's easier for the atom? Is it easier for it to receive 7 new electrons? Or is it easier for it to just get rid of this 1 electron? It's way easier, right? It's lazy like us. It takes the easiest path. So this becomes an ion. Remember, these brackets show that it's an ion. I really should have drawn more space, but ion. And it gets rid of this. So it's going to become... So we can't draw it here because I can't erase this out. So I'm going to draw it again here. Sodium. One, 2, 3, 4, 5, 6. I'm just filling it like this because I know it's going to be 8. So we're going to get rid of this. So we don't draw the last one. We just leave it like so. We don't need to draw in the new one to show that it's gone. We just need to draw it like so. So we draw it like this. And the 1 electron is gone, right? So it's now going to have a 1 plus charge. Because now there is 1 more proton than the electrons. Because one of the protons are gone, right? So it's going to have... sorry, not one of the protons are gone. One of the electrons are gone, right? So the negative electron. So it used to have 11 protons and 11 electrons. So the protons and the electrons are going to cancel each other out to have a net overall charge of 0. But now we lost 1 electron. So we still have 11 protons because the number of protons never changes. But it lost an electron so that it could have a full outer shell of electrons to become stable and unreactive. So now it only has 10 negative electrons and 11 positive protons. So 10 of these are going to get cancelled out. So we're going to have 1 proton left, and protons are positive. So there's a 1 plus charge. So we call this a 1 plus ion. Because it has an overall positive charge, so it's an ion. Ions are, remember, if it has a negative charge or a positive charge, it becomes an ion. The normal elements in the periodic table are not ions because they don't have a charge. Once they lose electrons or gain electrons, they finally become ions. Let's take a look at one last example, I promise. But this will help you to consolidate the idea. So let's take a look at calcium. Calcium has a ton of stuff, so it's going to be a bit confusing, but it's going to be fine. Calcium, 40 and 20. So this 20 is the atomic number. Tells us the number of protons. And the default state in the periodic table, it's equal. So the number of protons is equal to the number of electrons. So if we draw out a dot and cross diagram for calcium, I'm going to leave more space this time. So 2. Second shell can fit up to 8. Currently has 10. We're going to need one more, I think. So 8, 16, 18. So it needs one last shell. And this will be calcium's outer shell of electrons. I know this drawing's bad. So I know I said we fill it out clockwise, but it's more balanced if this one's just use logical sense. If you have 2 electrons in the outer shell, it's going to be here. If you have 3, it's going to be 1, 2, 3. If you have 4, 1, 2, 3, 4, 5 top, and then you fill the bottom. You know, it kind of makes sense, right? So 2 electrons in the outer shell of electrons. So it currently has 20 protons. Remember, the default within the periodic table, number of protons and electrons are the same. So currently this calcium atom is not an ion. It's just calcium. It's just a calcium atom. 20 protons and 20 electrons. And 2 in the outer shell. So this is very reactive and unstable. And it wants to become stable and unreactive by losing or gaining. So what's easier? So it currently has 2 out of its 8 electrons shells filled. Is it easier for it to receive 6 new electrons or to get rid of these 2 electrons? It's much easier to get rid of these 2 electrons, right? So what's going to happen is we're going to get rid of the last shell and we draw calcium again. So now we're only going to need to draw 1, 2, and 3 shells. 2 in the first shell, remember, and 8 in all the other shells. Once you get a hang of this and draw this a couple of times, you'll get used to it. And it becomes an ion. Remember, these brackets show that it's an ion. And it currently lost 2 of its electrons. Now it has 18 electrons because it lost the 2 in the outer shell to become a stable atom with full outer shell electrons. So 20 protons and 18 electrons. So now it currently has 2 more electrons. These 18 are cancelled out, but now there are 2 protons remaining. So it has an overall 2 plus charge because there's 2 more protons than the electrons. That's pretty much all you have to know about these dot and cross diagrams and the arrangement of electrons in atoms. Just one more thing, you can be asked to write them in just number form. So in number form, we start from the inside. So 2, 8, 8, 2. You just count them up and you write them in number form. So 2 electrons in the first shell, 8 in the second, 8 in the third, and 2 in the last shell, right? Now once it has become an ion, it's 2, 8, 8. So you just write the numbers based coming from inside out. That's pretty much all you have to know about ions, and I hope this makes sense. And I'll see you guys in the next one.